This section is on a very important topic, which is linear regression. This is very powerful for science, for studies, any kind of journal, anything where you're trying to look at data that you've already taken and use that to predict something that's going to happen in the future. This is a mathematical way of doing that. So, like it says here, we're trying to calculate a line that best represents a set of data points, and it is used to model trends and predict the future. It uses what's called the least squares method. You don't need to know that, but essentially it's trying to find a line that best represents the data. So these dots here, this would be your current data that you've taken, and you're using the line to represent that data, and then you can use that line then to predict the future. So the present is like over here, and the future is over here. So there's a lot of terminology. The correlation coefficient, which is R, this measures how closely your model matches the data, and the closer the number is to 1 or -1, the better the fit is. And two other terms, interpolation and extrapolation, that just is technical terms for, are you using the model to figure out points or figure out values that are within the data range, or to predict the future or outside the data range. So those terms aren't that important. So number one, there's a lot of stuff that we have to do on the calculator with this, and it can be kind of overwhelming at the start, but after you do it a couple times it doesn't become too big of a deal. You can always refer to these steps though. There's actually 4 main steps that you need to do. So there's a lot of buttons, but it kind of always boils down to 4 steps, and you can always refer to this this chart here. So it's kind of like when you get a new phone, it takes a while to get used to it. So with these calculator commands, it takes a while to get used to them, but once you get used to it, it's not too big of a deal. One thing that we do need to do before any of this, and this should be a one-time thing, you shouldn't have to do this more than once, and that is the Diagnostics on. So you want to go to Catalog, and you want to turn your diagnostic on. So that's going to look like this. So the catalog, that is like at the bottom of your calculator. So if you press that button and then scroll all the way down to Diagnostics on, then you want to make sure that you press enter and then turn that on. Okay, so our first step after that, again, you should only have to do that once, but the first step is you want to go to the Stat, Edit, and then Edit. So if you press the Stat button, which is right here, you'll see that we're under the Edit menu, and you want to press Edit the command. And that'll take you to a place where there's 2 lists, and, well, more than 2, but we're only using 2. And you want to enter in the X values and the Y values. So your X values into L1 and your Y values into L2. So you're just entering in this data. So you type in the number, press enter, and it will take you to the next entry. So that's how we are entering in this data right here. Okay, after you do that, then you need to calculate the line that's going to represent this. So that is the stat calc linreg, or linear regression. So let me go to that. Again, you want to press stat, and this time instead of the edit, you're under the calc part of the menu, and you want to do the linear regression. So then if you press enter and then press enter again. Depending on your calculator, you may have a version where you need to go down. It may give you like a menu with maybe 5 or 6 options, and then you go down, you just press calculate again, and then it should get you to this screen here. But this is where our information is for figuring out this line, because our line is a line of slope-intercept form. So this is y is equal to ax plus b. I don't know why they don't have y is equal to mx plus b, because then it would be consistent with our slope-intercept form, but y is equal to ax plus b. And these are the numbers that you want to plug in there. So it's going to be y is equal to negative 0.6x plus 10.2. So let me go back and write that in. Y is equal to negative 0.6x plus 10.2. And then they want us to graph it. So if I look back up at my directions, I want to go to the y equals menu. I want to turn plot 1 on and type the equation. So let me show you what that looks like. If you go to the y equals menu, you want to make sure that this is shaded. So if you press up and then press enter, you should be able to have that turned on or shaded. And then you want to type in your equation into your y1. And then the next step is you want to do zoom and zoom stat. So if you do zoom and then do zoom stat is going to give you a window which is tailored toward your data points. So if you press enter there, then this should be your graph. So those are your data points, and that's the line that's representing that data. So I want to copy that now here. And it doesn't need to be perfect as long as it's somewhat close to the actual picture. That is our data points and our regression line. So the points are these data points, and the line is this line. Part C says, how well does the model fit the data? Well, first of all, we already did this part here with the zoom stat. So the correlation coefficient, that is just your R value. So let's go back and find out what our R value was. Let's see, it was right here. So your R value is, and I'll use 3 decimal places. So it's negative 0.875. And again, we're always measuring this and how close it is to 1. So the closer it is to 1 or negative 1, the better the fit. Negative 0.875, that's pretty good. So you can say good, you can say pretty good. Doesn't really matter. And what that means is that the line is pretty close to these data points. We don't have like a data point way up here or way down here. They're all pretty close to the line, and this number is telling you that. So if you're in like a science journal or some kind of market research where they're using regression, which they do, you can calculate a regression on anything. The calculator will do it. But if this number here was like 0.1, then it wouldn't really mean anything. So when people are reviewing other people's work, always check this number here, because if it's like 0.1 or 0.01, then they did the math, but it doesn't really mean anything because it doesn't represent the data very well. Okay, so let's go to part D. So part D, now we're using the model. So we have the regression line, and we're trying to use it to find things. So there's not really context here. We will look at one where there is some kind of context to the question. But here it says, use the model to find the value of y when x is equal to 15. So basically all we need to do is plug in 15 for x in our equation. So our equation that we made was y is equal to negative 0.6 x plus 10.2, and I know what x is, it's 15. So if I calculate that, then y is going to be equal to 1.2. And that'll be our answer. Part E says use the model to find the value of x when y is equal to negative 4.8. Here, I want to plug negative 4.8 in for y in our equation. So I'm always referring back to that original equation of negative 0.6x plus 10.2. So this will be negative 4.8 is equal to negative 0.6x plus 10.2. And I want to solve for x. So if I subtract 10.2 from both sides, I get negative 15 is equal to negative 0.6x. And then if I divide both sides by negative 0.6, then x is going to be equal to 25. So a lot of steps on this one. It takes some practice, but once you get used to it, it's not quite as bad.